Think about what happens when you step into a shower. You turn a single knob, and the plumbing behind the wall mixes the hot and cold water streams together until the temperature feels exactly right. We do the exact same thing when we get into a car. You adjust the climate control dial to a comfortable 72 degrees, and the air blowing on your face feels perfect. Curious, but there is no heavy water pressure pushing things around inside your dashboard. So what physical mechanism acts as the faucet to push and mix the air? To find out, we have to look behind the plastic and into the dark, complex maze of tunnels hidden inside your car. This entire temperature system relies on a single hidden mechanical component that listens for an electrical signal every time you touch that dial. Achieving a comfortable cabin requires a lot of mechanical effort. The car has to perfectly blend two extreme hostile environments together, entirely out of sight, just inches from your knees. This 3D schematic shows how the process starts. Air flows into a glowing blue block called the AC evaporator, chilling the air. Further down the tunnel sits the heater core, pumping out intense heat using scalding engine coolant. The main blower fan pushes a massive amount of air continuously through both extreme temperature blocks at the exact same time. To control all this air, the system uses a tiny traffic cop. It's called a blend door actuator. It looks like a small plastic box filled with little interlocking gears, driven by a tiny electric motor. When you turn the temperature dial on your dashboard, it sends a direct electrical message to this actuator. That signal tells the tiny motor exactly how many degrees to spin its gears. Your car never actually changes the physical temperature of that freezing cold evaporator or that boiling hot heater core. The actuator simply dictates which path the air is allowed to take to reach you. This top-down diagram shows us how the actuator works. The motor's gears are attached to a hinge, swinging a plastic flap, the blend door, to block or open specific airways. If the motor holds that door halfway open, the hot and cold air streams crash into each other, swirling together in this chamber to create mild, comfortable air. That works perfectly for one person. But what happens if the driver wants freezing air and the passenger wants high heat? Looking back at our diagram, a solid divider wall drops straight down the middle of the tunnel, perfectly splitting the airflow right after it leaves the cold block. We can now place an independent actuator and blend door on each side. The driver's door can completely block the hot air, while the passenger's door blocks the cold air. To give you dual-zone climate control, car makers don't need to install two entirely separate air conditioning systems. They simply divide the tunnel and use two of these actuators to mix two independent recipes of air side by side. That little motor has an immense workload. Those internal plastic gears make constant tiny micro-adjustments every single time you touch the dial. After years of daily wear, tear, and friction, the plastic finally gives out. A single tiny gear tooth snaps off inside the box. The electric motor keeps trying to spin, but the broken gear slips. With nothing holding it in place, the heavy plastic door swings limp, usually getting pinned open on the hot side by gravity and airflow. As the motor turns and the broken gear slips over and over again, it creates a repetitive, rhythmic clicking or tapping noise coming from right behind your glove box. Because the physical door is completely stuck, the air blowing out of your vents will remain at an extreme temperature, often boiling hot, completely ignoring whatever you set on the dial. A clicking dashboard and stuck vents usually point to one specific thing. You rarely have a massive, expensive AC failure on your hands. You simply have an overworked, tiny dashboard robot that needs a new set of gears.